So here I want to introduce the first formal lesson of Math 9, which is talking about rational numbers. And the first chapter is looking at rational numbers, which rational numbers pretty much include just about everything you can think of. Rational numbers are any numbers that can be expressed as a fraction. And if you look at the word rational, the word ratio is buried right in there. And a ratio, if you think of a ratio like a 1 to 2 like that, that can be written as a fraction, 1 over 2. And fractions, when you think of fractions, they're essentially a ratio between the numerator and the denominator. So when you see the word rational numbers, we can think the word fraction. Anything that can be expressed as a fraction. It doesn't actually have to be a fraction necessarily, but if it's possible for a value to be expressed as a fraction, exactly, then it's a rational number. For example, 1/2 is a rational number because it's just 1/2. So, that's pretty obvious. But 1.5 is a rational number because I can express 1.5 as a fraction. 1.5 I can express as 1.5 or 3 over 2 as an improper fraction. They're all equivalent. And so 1.5 is a rational number. So is 1.5 and 3/2. They're all the same thing, just different ways of writing the same thing. 2 1/3 is a rational number because I can write that, well, again, right now it's a mixed number, but I can write it as an improper fraction. In this case, again, 3 times 2, add it to the top, you get 7/3. And again, anything that can be expressed exactly as a fraction is a rational number. 5 is a rational number because I can express it as a fraction if I think of it as 5 over 1. There we go. And same thing with negative numbers. Negative, just because it's negative doesn't mean it's not a rational number. For example, -5 I can think of as -5 over 1. -2.6 repeating. If the decimal repeats in this case, then I can express this exactly as a fraction. This is the same as -2, and 0.6 repeating is the same as 2/3. 0.666 forever is the same as 2 divided by 3. And -2 over 3, if I change to an improper fraction, 3 times 2 is 6, add it to the top 8, so I have -8/3. But again, most importantly, all of these are, again, rational numbers. And the square root of 9, which means what positive number times itself equals 9? Well, that's 3. And I can write 3 as a fraction as 3 over 1. So again, everything you see here, 1/2, 1/5, sorry, not 1/5, 1.5, 2 1/3, 5 whole, -5, -2.6, and the square root of 9, all of these things, everything here is a rational number, which can make you believe that everything is a rational number. All numbers are rational numbers, but that's not the case. Irrational numbers are numbers that cannot be expressed as a fraction. And here's 2 examples, pi and the square root of 5. Pi, again, is approximately 3.14, but I don't care how many decimals you memorize it to, it's not exactly that. And there is no fraction that is exactly the same as pi. It's approximately the same as 22 over 7, but it's not exactly the same. So you can approximate pi with a rational number, but it's not exactly. There's no way you can write pi as exactly just a fraction of one number over another. And the square root of 5. If you go to your calculator, if you decimalize the square root of 5, you see a decimal that kind of fills the screen. It's approximately 2.236, but no matter how many decimals I write down, there's no pattern. It's not like the pattern numbers start to repeat after a while, and it's only limited by the size of your calculator screen. And the square root of 5, again, is not a rational number. So there's actually an infinite number of rational numbers. There's an infinite number of irrational and rational numbers, but the focus of this first chapter is mostly dealing with rational numbers. All right, so all I want to do now is how can we put these rational numbers here in order from least to greatest? And there's always more than one option, but one thing that's can be quite useful is a simple calculator. But that said, just by looking at these, it's hard to tell. I have different rational numbers in different forms. Chances are, though, if you decimalize them, you make it much more obvious about the order. And quite often, when you decimalize values that have fractions, it makes it much more apparent about what's larger and what's smaller. So 1 3/4, now that's it. You may just know what 3/4 is as a decimal. I mean, if you have 3/4 of money, you have 75 cents. So 3/4 is 0.75. So 1 3/4 is 1.75. Now 5/6. I don't expect you to know off the top of your head what 5/6 is as a decimal. So if you're not sure, so you can do this for any fraction. I can just look at 5/6 and realize this means 5 divided by 6. And so I can just go to a calculator, type 5 divided by 6, and I get 0.8333 repeating. So just 5 over 6 is the same as 0.83 repeating forever. So 1 in 5/6 is 1.83 repeating forever. So now I can see with certainty that 1 in 5/6 is more than 3/4. I could also figure that out by finding a common denominator and stuff. Again, there's lots of approaches. And so now I can see, compared to 1.8, I can see 1.8 is between these. What about 8/5? I could change it to a mixed number. 5 goes into 8 once, and there's 3/5 left over. That's it. Again, I have a different denominator, and so you may know what 3/5 is the decimal, or you can go to your calculator, go 3 divided by 5, you get 0.6. So this is 1.6. And lastly, the square root of 1.96. That means what positive number times itself equals 1.96. A great example of when to use a calculator. The square root of 1.96, and I get exactly 1.4. My calculator screen is not filled up with decimals. It's 1.4 exactly. So it's not rounded. It's exactly 1.4. And so now, if I look at these, I can see the least is at 1.4, or the square root of 1.96. The next smallest is 1.6, or 8/5. Next was 1.75, or 1 3/4. Next was 1.8, and the largest value here was 1.83 repeating, or 1 5/6. So that's the greatest. So like I said, chances are the order of these rational numbers became much more apparent once I decimalized them. And if something's a rational number, you can always find an exact decimal. The decimal may repeat, but always has some sort of pattern. Whereas pi, or the square root of 5, the decimal doesn't repeat and it actually goes on forever.